Good afternoon and welcome to today's webinar, ISO 14119, the new machine safety standard for Guard Door Interlocks, presented by EHS Today, New Equipment Digest, and Machine Design. Today's webinar is sponsored by Schmersal. My name is Steve Bush. I'm the managing editor of New Equipment Digest magazine. Before we begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit the F5 to refresh your webcast console. If you need assistance solving common issues, please click on the Help button below the slides. We welcome your questions during today's event. Just type your question into the question window on the side of your screen and hit the Submit button. We will answer as many questions as possible during the Q&A session that will follow the main presentation. But please feel free to send in your questions at any time. Please also be aware that today's sessions are being recorded and will be available on the Machine Design, EHS Today, and New Equipment Digest websites within the next week. You'll be notified by email when the archive is available. Our speaker today is Mike DeRosier, who is a TUV Certified Functional Safety Engineer for machinery. His 20 years of experience include controls engineering to design, build, and integrate full machine control systems. His safety experience led him to help corporations develop corporate safety standards, perform machine safeguarding risk assessments, machine safety training and design, as well as implement safety systems for all aspects of machinery: electrical, electronic, pneumatic, hydraulic, and mechanical. Mike will now proceed with the presentation.
All right, thanks, Steve. Good morning, good afternoon, everybody. Appreciate you jumping in and learning about the new ISO 14119 standard. Exciting in the world of standards that we yet have another global harmonized standard to talk about when it comes down to machine guarding. When we talk about ISO 14119, we're going to talk about just some of the nuances or some of the highlights on what the standard incorporates over its predecessors. So in doing that, a couple of the things with this standard, the ISO 14119 is a Type B2 standard, which is not specific to a machine group as you would see in a Type C standard, but it is specific to a group in regards to what you're doing for guard door interlocks on machinery. The predecessing standard was EN 1088, which has been around for quite some time, but things have changed over the years. Technology has changed, and the standards had to come up with the times and incorporate some of the things that they've learned over the years and some of the newer technologies. The fact that this was published in September 2013, for those involved with the European Union and CE marking, this takes into official European Union law with the CE standards as of April 30th this year. A couple of the highlights that we are going to talk about during the presentation today is going to be locking as a separate function. And what we mean by that is whenever we required door locking as a safety function, we always saw the switch or the operation of the door to be closed and locked, not necessarily door close as a function and door lock as a function. And that's one of the things that have come about in this standard, is looking at those as two separate functions. We're not only looking at the components, but for the machinery manufacturers that are developing this, as well as the end users and what we're doing. We'll talk a little bit about that, and then the new requirements for safety sensors. As technology has developed with getting into more of the electronic type of devices, electromagnetic type of locking switches, or pulse echo or RFID type of safety devices, where do they really fall into the mix of this standard? And a huge section that we're really going to talk about today that is just as important as any of the other sections, but going to spend a little bit of time at toward the end here, is what they're talking about with tamper protection, which has always been a discussion over the last several years on how much do you make it difficult to defeat? What are the methodologies? And the standard actually addresses that, which is important. Now, even though we state that it takes effect in April 30th in the European Union, one of the questions that come up is, well, this is not adopted by Osha as a federal government standard in the United States, for example. Does this standard really apply to people in the U.S. or with CSA for Canada? And the reality is it does. This is a international standard. It's global, it's harmonized, and it proves of methods and principles and practices to improve the overall safety of the machine. So it does take effect over here as well. What you're going to see, and it's away from the traditional way that we definitely like doing PowerPoints with having a lot of verbiage on the screen, and we're not expecting everybody to read all the words that are on here, but what you're going to see in the boxes is actual excerpts from some of the standards that relate to ISO 14119, as well as 14119, the standard itself. So in this particular case, here is an excerpt of 1.4.2.2 when talking about interlocking movable guards, as referred to in the machinery directive for CE. In looking at that, if you highlight some of the sections and you see what's highlighted in yellow there right now, that any movable guard must be associated with an interlocking device that prevents the start of hazardous machinery function until the door is closed, but also will initiate that stop command. So what that means is monitoring of that door position is required, and what that means is using the proper safety device as outlined in 14119. The other section you see in here that you see highlighted, the guard locking device in addition to an interlocking device, whether the door is closed and locked. So there's two different definitions. You have what's referred to as guard locking, and you have what's referred to as process locking. Guard locking is when you are locking a door because of some sort of residual energy, motion, hazard that's present in the machine that takes time to dissipate or under a controlled initiative to take away that hazardous energy. You need to keep the door locked and closed to keep people safe until that energy has been removed, that hazardous motion, whatever the actual hazard is, has been alleviated from the machine for people to safely enter. Then you can unlock that door. Process locking deals with protection of the process, where as long as the door is closed and you open it and initiates an immediate stop and not hazardous to the person, but you may want to lock it for process reasons, which doesn't necessarily have to be monitored as a separate function. So knowing that the door is closed and the door is locked are two distinct functions when you look at safety considerations on the machine. Going through your risk assessment process is what's going to help you determine that. Now also in the machinery directive, what we're seeing here is one of the highlights is that the guards and the protective devices must be securely held in place. And sometimes that definition of securely being held in place gets into a lot of gray areas of what kind of hardware does it really mean. ISO 14119 also talks about the types of devices, the type of hardware, and the type of protective measures you put into place just for protection of those devices from tampering and defeat. So unscrewing an actuator or switch is not the only way defeating, and you want to be able to make sure that the device is not easy to bypass with other units or spare actuators, as well as not render the unit not operational, talked about in this particular chapter. So you see interlocks need to be able to should not be able to be easily defeated, easy to bypass, and render non-operational. They have to be functional to protect people from getting seriously hurt. In doing that, when you go through your risk assessment process, what that also may mean is what additional measures do you have to incorporate to minimize that type of manipulation from even occurring. Now, when we look at the actual standard, the standard has a table in there that talks about the different types of switches. You got mechanical and non-contact, and different types of technologies revolved around that. Uncoded and coded, that you see highlighted in that red box there, and we'll talk a little bit about that. And something that's new in the standard is the Type 3 and Type 4 type of devices, where previously it was really the Type 1, Type 2 with coded magnetic type of switches, but now that we got a separate section with non-contact, we now have the Type 3 and Type 4, and we'll show you what those different devices look like. When we look at Type 1, Type 1 is considered an uncoded mechanical type of device, such as a safety-rated limit switch or a hinge switch. There's no separate actuator, so there's no coding involved, where the function of the safety has to deal with the additional installation and the measures. There's no separate actuator to create any additional issues. A Type 2 coded is still an electromechanical device, whether it be a locking or non-locking type of device, but it has a separate actuator where you have a coded actuator. Doesn't mean it's necessarily independently or individually coded, where it's a custom code for that particular switch, although it can be because there's different coding levels that we'll talk about. But it's uniquely coded that you can't take a standard piece of metal or actuator to bypass the device in question. Type 3, we get into the non-contact versions, where you actually have an uncoded, where it may not necessarily be a coded magnet, or it might be a distance off of proximity, but again, it may or may not include a separate actuator. And then the last type is a Type 4, which is coded, where you actually have a unique RFID field or a unique coded magnetic arrangement that creates that type of coding. Again, could be a simple code, and it could be a multi-use type of code that we'll talk about the codings in a few slides. They're the 4 different types that are now laid out in the new ISO 14119 standard. Now, when we look at locking, one of the questions that have always come up is, as a safety consideration, should we use energized to lock, or should we use energized to unlock? What is the true safety definition? What is the safer? No matter what you come up with, it really does come up to your full risk assessment to determine the proper use of a locking device. But the statement, I cannot use a power to lock as it's still allowed and it's not allowed in a safety system, is not true. ISO 14119 specifically calls out, as you see on the slide, whether you have a spring to lock and energized to unlock, or the next set of pictures, it's a power to lock and then spring to unlock, or some of the conceptual that some of the manufacturers are working on is a locking methodology where you energize to lock as well as energize to unlock. Those 3 different concepts are clearly discussed in the standard. And when you thought that energize to unlock was the only type of safety device that was allowed, that's not true, as you see per the standard. But what is true is you really have to determine by your risk assessment what is the better condition. If you have a serious hazard potential with loss of power that allows that unlock to occur, that somebody can get into, and that's a foreseeable, reasonable type of hazard, then you may want to go to the power to unlock type of scenario just to accommodate for loss of power in that particular situation. But your risk assessment is really what's going to help you try to determine that. Now, in addition, something that's new in the standard is electromagnetic locking, which comes back to the point of whether you need energized to lock or energized to unlock. You can use both as a safety function, just determined by your risk assessment. But one of the requirements laid out in the new standard is when you have an electromagnetic type of device, as you see in that figure 5 there, because the switch doesn't physically get damaged, you have to require a 10-minute reset timer to basically simulate a repair-like condition, because the electromagnetic doesn't physically get damaged when somebody forces it open like you would a mechanical type of key device. So the standard requires that reset timer in order for that locking function to be used as a safety device. Something else that gets into in there is the actuation modes. When you use the Type 3 type of devices or Type 4 type of devices, it has to meet the requirements of IEC 60947-5-3. What you see is -5-1 deals with mechanical switches, 947-5-3 deals with non-contact or proximity type of devices used for safety conditions. So some of the questions that often comes up is when determining whether a non-contact is a safety-rated device, well, does it meet the 947-5-3 to be used as a safety device? That's your telltale on knowing whether the devices you are currently using on a machine, are they safety rated? Do you have the documentation that states it meets those design standards? Now, interlocking devices associated with guards, and what we're talking about is when we're concerned about door locking because of residual energy or motion that can cause a hazard, something that's come up from this standard is defining the lock as its own function and knowing that the door is closed and locked, for example. What they're looking at is the contact arrangement, because you can have contacts that monitor just the door position. You can also have contacts that monitor the door position in conjunction with the lock to know that the door is closed and locked for your safety function. But something that is new now is when you have a safety device that is used for a locking for safety protection of personnel, there's a new IEC symbol that you see in red on the screen right now that indicates that that device has been approved or designed to that particular standard to be used as a safety function. However, one of the questions that will come up is manufacturers of any safety device that uses guard locking as a function, it doesn't mean that that symbol has to be imprinted onto the device. They can. It's not required per the standard, as long as you have that symbol marked in your installation instructions to give you that documentation to back you up, saying that those particular contacts are allowed to be used for a guard locking function. Now, in addition to this, one of the things that we look at when we look at the release of the guard locking device, one of the notes that they put in the standard, you see highlighted in yellow there, is unintended unlocking of the guard and reaching a safe condition of the machine or a dangerous situation, the safety function for guard locking. What we're highlighting there is if you have any unintentional locking and it can lead to a dangerous condition, then your risk assessment, your risk analysis really needs to be performed for that particular function to determine, do you have the right device? What is a safe state? What do you get to? And your risk assessment is dictating that you need to do certain actions based off of that particular function and how you actually control it. The next thing we're going to talk about here is what you see in this particular note. In conjunction with that, you see my note down there that the PL, which stands for performance level, comes directly from ISO 13849. The performance level of the locking function is in general lower than 1 for the interlocking function, which is the door condition, knowing the doors open or closed. When you go through your risk assessment process, all they're trying to state here is when you go through that risk analysis, you may find that your door locking function most of the time isn't going to need to be nearly as high as what your guard interlock function needs to be. So when you look at the unintentional unlocking, meaning that loss of power, the likelihood of that were to happen when you go through the full 13849 Part 1 and Part 2 of designing your system, going through your risk assessment, and going through your validation and your fault exclusions, the chances of that happening and what's needed, you're going to typically find that the unintentional unlocking of a guard door is going to be a much lower performance level than the guard locking function itself. And I know that sounds a little strange right now. As you get into it, it will definitely make more sense. But if you have questions on that, please type them into the question field. We'll answer them the best that we can in this particular case. Something else that kind of highlights in the standard is sometimes you get into questions about locking. Because different manufacturers, all their different models, they all have different locking, or I should say holding forces when it comes when to the switch is actually locked. What is the real holding force? What the standard is highlighting here is they're not providing what a minimum door holding force requirements are, because the standard on a basis can't. It all comes back to your risk assessment. When you look at the risk factors, what's the chances or what are the capabilities of people forcing a door open under a locked condition, and what are those forces needed to open it? The guard design has an impact. So, for example, if you have a switch that has 100 pounds of holding force versus a switch that has 200 pounds of holding force, what's the difference between the two? Because they're both locking, safety-rated type of devices. It might be in the design of the guard, where the guard design may warrant the 200-pound holding force because of the mechanical leverage that can be put on there, versus the 100-pound of holding force and mechanical leverage may say that's not enough and we're going to force it open with very little effort by the operator. Doesn't mean that the lower switch doesn't have its application. It just means that particular application may not be right for it, where most of the applications you do run into do have that lower holding force is more than enough, where 100 pounds is plenty of holding force under a locked condition. So it comes back to that the standard is not trying to dictate to you to say what holding force you need and force you to change your design. It's saying if you determine that you need to have a locking as a function, you need to determine by your risk assessment what are the locking forces required by design, and you can document what you came up with. In addition to the locking holding forces, you see that the no specific minimum is there, but what also usually dictates a locking holding force might be that Type C standard, meaning you may have a certain Type C for a specific machine, such as the ANSI B65 standards for printing presses, or the RIA 1506 or 10218 for the robotic standard may have a certain locking force based off of those particular type of machines. That Type C standard may dictate what your locking forces may be. If not, then you go by what you see in your risk assessment. Another consideration that a lot of times when you design your guards, something that's not taken into account is the dynamic forces associated with locking devices, especially when you're using an energize to unlock, or you initiate the lock command before the door is actually closed. Whenever you close the door, you have to look at what the dynamic forces are, and what the standard is meaning by that is looking at what the door is actually doing. Is there bounce in the door? So if somebody goes and just slaps the door, slams the door closed, it engages the actuator to the switch, but is there some bounce back because it hits a surface and bounces back, and does the locking mechanism account for that door bounce? Can it handle that in the guard design or the switch design? Is there a way to minimize that bounce back so you don't damage the switch and put those dynamic bounce back forces that if you exceed the locking force, you can actually damage your switch and actuator? So when you're looking at your guarding design, look at not only the fact that you have to have it closed and locked, but look at the foreseeable use on it, and is there bouncing, and how do you minimize that bouncing impact on the switch, whether it's built into the switch to handle it or external on the door frame and the door to soften those bounce backs so you don't get those mechanical forces hitting that switch that can cause that switch to become defective for you. Now, another aspect that the standard kind of highlights, and something that's hopefully is going to be released in the next few months here, is there is an ISO committee that formed, or in the middle of forming, a technical report right now called the ISO/TR 24119, and it deals with using safety interlocks and what are the considerations with tying them in series, or what's referred to as daisy chaining. A lot of questions come up with daisy chaining because it is one of the most common methodologies you see out in machinery. Their switches are daisy chained to one safety monitoring relay, for example, as you see in that picture. But knowing what the repercussions are, what the faults that can occur, what is fault masking, what are fault exclusions, what are the things that can happen, what control category do you really meet, or performance level, no matter what your calculations come out to, what is your performance level, what is your diagnostic coverage when you're implementing a standard like ISO 13849. So in this particular section, in 8.6 of ISO 14119, they're laying that out, but basically telling you that the TR 24119 will be coming out. It's under preparation. The last I heard that it's due out sometime in, I think, the second quarter, but like with any standard, you really don't know until they finalize it and do the official release. So keep on the lookout for that, because that'll help clarify series circuits a little bit more than you've ever had before in any standard. Now, to me, this is something that we tend to see a lot more than what you would think you would see, but the standard really gets into tamper resistance and how do you provide those protections. And what was done, particularly in Europe, there was a study done by BG, which is a test agency in Germany. They developed a protocol, or a report based off of surveys that were done. They basically surveyed 1,000 field experts in safety, as well as done some actual field or site surveys, and came up with some interesting results. And SUVA, which is equivalent to Osha in Switzerland, did a similar report and actually came up with very similar results. And what they were particularly looking at, as you see in the pictures there, is intentional and willful bypassing of safety devices. So here you can see in the first picture on the left, somebody developed and fabricated to the extent of a key to simulate the door being closed so they can run that machine in full automatic mode while that door is open. Or the ever so common having a spare actuator on a set of keys, as you see in the middle picture, and even to the extreme where people have found contactors. I know it might be a little hard to see on the screen, but if you look closely in the center of the contactor, that's basically either screws or nails that have permanently held that contactor on to keep power on that unit, which is obviously a huge no-no. And you start thinking, why would somebody go to those extremes? Tamper resistance, or people tampering with guards and safety devices, it is an issue, and it leads to a very dangerous condition on a machine. So a huge section of this standard really deals with tamper protection. And one of the reasons you see by the results of that study that I just talked about, you can see some of the results in these pie charts here. When they went and did the study, they looked at first the percentage of bypass guards. And what they found out of all the guards that they went to was 14% of them were temporarily bypassed, and 23% was permanently bypassed. So 37% of the guards that they surveyed had either temporary or permanent bypassing occurring with that guard. That is a huge number, and that doesn't seem to be realistic, but this is what the study has proven. Obviously, with the increased safety risk, one of the questions came out, do you feel that because of that you're at an increased safety risk? And it was split down the middle, which is kind of interesting, that people felt that, or I should say that many people felt that they weren't at an increased safety risk with the temporary or permanent bypassing. The accidents that have occurred in the fields that they studied over in Europe was that 25% of the accidents or fatalities were due to bypassing of safety devices. And then the last figure that I thought was real interesting was the company acceptance, where 34% said that their company accepted that as a common practice. Obviously, you can see by these pie charts from this study done by BG that this is an issue. And whether you're an end user, you walk out on your floor, or an OEM that visit customers, take a look to see how much of this is really being done. And part of your walkthrough is you have to open up the guards. You have to check them. You have to see. You have to do periodic checks to see what's going on with them and why this is actually happening, and fix it before it becomes an issue. Because the last thing you want to get to is fix it after an accident occurs. So as a result of those studies, they have added some verbiage in the ISO 14119 standard, and they were defining what defeat is, as well as defeat in a reasonable manner. And what does that mean? When you look at what's highlighted there, defeat makes interlocking devices inoperative or bypasses them. The defeat in a reasonable, foreseeable manner, whether you're manually or using readily available objects, such as tools. One of the most common questions whenever we talk machine safeguarding is the defeat and whether it's considered willful intent if somebody has the tool. If they actually get a tool to remove a safety device, is that not considered willful intent because they got a tool? It's not. And it's, again, highlighted in this standard as well as you see in other standards. But here's another clear point that's saying when people are given common tools, so as you see in this note 1, using tools that are needed for the intended use of the machine. For example, when you give an operator a set of hex keys because that's part of their job, they have to do machine setup or machine changeover. You provide the hex keys to them in order to perform their job function. Well, when you use guard doors or hard guards or the hardware that holds the safety switch or the actuator in place, and you put socket head cap screws or button head cap screws that use hex keys, that is a common tool. That is something that is readily available and is not accepted because it can be reasonably and foreseeably defeated. Or using, in Note 2, you see readily available objects for suitable actuation, such as having the replacement key, being able to tie something down. Is it properly installed? You can do that to the best of your ability, but what we mean here by everything else cannot be prevented is if you have a cultural issue and somebody goes to the extreme, such as that one picture of opening up a controlled electrical cabinet and bypassing contactors by inserting screws into them to keep them on all the time, you can only design so much before you have to deal with the culture, and knowing that you have to prevent that from occurring. And if it means eliminating an employee position because of that, they're putting themselves as well as other people at risk whenever they perform that kind of defeat or bypass. So what they look at when they look at defeat of interlocks is look at the coding levels. When we say using the type 1, 2, 3, and 4, so the type 2, type 4 as coded versus uncoded, they talk about low, medium, and high. And what that really means is the coding possibilities. Low is from 1 to 9, medium 10 to 1,000, and then high is greater than 1,000. It's just the idea of going through and looking at what the different coding levels possibilities can be to make it more tamper resistant for somebody working with the machine. Now what they did is they added this figure 9 here. And what that figure 9 is going through is just a decision tree. So you go through that decision tree based off of your risk assessment, and obviously you implement your basic measures, but then you have to ask the question, is there a motivation to defeat? It's easy to automatically say, no, there's no motivation to defeat. But what you find in reality is there probably is a motivation to defeat, whether it's out of a convenience factor or an operator feels they can get their job done quicker because, let's face it, an operator's job is to produce. If they run into that issue, they have to look at whether you can easily defeat a guard and they feel that they can perform their job function better. So that first thing you do, is there a motivation to defeat? If there isn't, you can justify that. You probably have your basic measures implemented and you're good. But reality is when you saw the results of the BG survey, there could be a high likelihood that there may be a motivation for defeat. So now you have to go to the next section. And what does that entail? It looks at the Annex H. And Annex H, you see, gives an example, in this case, an automatic machine tool like a CNC machine. You'll see the different functions that occur or the tasks that are performed on the machine. So what the standard is giving you is not just a yes or no answer, but go to Annex H as an example. You go and develop your tasks associated with that machine and go through those different tasks and determine, do they need to do this, do they need to do that, and find out if they're motivated to defeat. And by that, you can come up with those different modes and whether you have any true motivation or not. That takes you into the next step. So your next step following would be looking at that chart and determine that one of the things you can do is eliminate or do something in design to get rid of the motivation for defeat. So whether it's in design measures or implementation of alternative modes of the machine, you can look at different aspects of your machine design. What do we mean by that? As you see some examples here. Well, why are people motivated to defeat? Well, one of the first things could be they can't see what's going on. If you design guards that are easy to see through, whether it's a black mesh versus yellow mesh or having clear glass or Lexan, so you can see everything that's going on into the work area. It's clear, it's clean. When they can't see what's going on, and whether it's a maintenance function trying to troubleshoot, or whether it's somebody trying to figure out what the machine's actually doing on a normal production basis, when they can't see it, you got your motivation to defeat because they want to be able to open up the door while the machine's running so they can see what's going on. Making sure you have that covers. Making sure your control elements are outside the machine, not inside. So when you retrofit a machine and you put guarding and leave the controls inside, well, they have to get inside to get to the controls. Thus, they're motivated by defeat. So some of the simple measures to eliminate that. In doing that, when you look at another reference in the machinery directive, they're talking about how some of the conditions cannot be fulfilled simultaneously, such as special operating modes, which are also active in Type C type of standards. So robotic, being able to teach. Do you have a setup mode or a tool change mode? Those Type C standards call out what are the additional protective measures that have to be activated during those modes, and you want to have that clearly defined and ensure they're put into place. Now, when we look through the steps, 1, do you have the motivation? 2, put your countermeasures in place. And 3, this is your last chance that if you can't put those countermeasures in place, what do you do from that point forward? So what the standard gives you is Table 3. And what Table 3 is you can see the title, Additional Measures Against Defeating Interlock Devices. So when you look at the table there, you look at the type of device, a Type 1 locking, hinge device, Type 2, Type 4, Type 3, trap keys. So here you can see what is mandatory and what are recommended measures on the chart. So when you use non-detachable fixing on position switches, so if we look at a Type 1 device, whether you're using mounting out of reach, all those things are required per the standard. Or, I'm sorry, all those, at least one of those are required with the X on there, and it's also recommended to put additional interlocking devices on there. So we'll give you an example of that. So when you look at the Type 2 device here, for example, with a separate key, what's mandatory is selecting either mounting out of reach, concealed or conditional monitoring, concealed mounting or conditional monitoring, and using non-detachable fixings on the actuator. The recommendation is to put a second switch as well as doing plausible checks on both switches. When you look at standards, a lot of this has never been defined in previous standards. Here is now a standard that is clearly defining what is definitely required and what's the additional recommendations that you should put on switches based off of the control to try to prevent defeat of interlock switches. When you go up into a Type 4 device, you can see that a Type 4 highly coded devices, the only mandatory thing is to make sure the actuator has non-detached fixing of the actuator. So you're using tamper-resistant hardware such as one-way screws, where they can't take a tool to remove that hardware from the unit. I know we've gone on a lot of information. I know there was a lot of verbiage, and I apologize for that. But I know it's one of the ways to really get through some of the key highlights of what ISO 14119 is. And if it's something you're interested in, we definitely have a brochure available that you can contact us. We'd be happy to send you either the hard copy or a PDF version of the brochure that looks at both 13849 and 14119 and some of the implementation and concepts that 14119 has come into it, just as an additional resource for you. So at this point in time, Steve, let's go ahead and open up to questions.
All right, Mike, thank you very much. A few of you have already submitted questions, so we're going to jump right in. While our presenters are answering your questions, please take a moment to answer the feedback form that appears on your screen. If you do not see the form, please click the red survey button at the bottom of your screen. Question 1. It appears that this standard creates a higher standard of care for OEMs as well as purchasers and employers. Is this how the standard is viewed? Do you see ASSE, Prevention Through Design, and others educating their members?
I think long term, definitely. Just like you see with I want to say not the very first, but one of the first, I think, well-known standards over the last several years. ISO 13849, for example, has developed a new way of looking at the safety-related parts of a control system. And when you look at a lot of standards, and I can cite specifically a lot of the ANSI standards, when they look at the updates of their standards, they're actually incorporating the concepts and principles of ISO 13849 in those standards. And I see ISO 14119 doing the same exact thing, where this will get more incorporated because it proves and shows better principles of practices and addresses some of the major concerns that we've seen over the last several years of what has happened in the migration of safety technology, where has safety technology gone to, but also because there is history of, as we showed in the BG report, the fact that guards are being defeated and they shouldn't be, and it's leading to serious harm, is an issue. So I can definitely see a lot of the standards committees and organizations start incorporating 14119 just like they've started doing ISO 13849 as an example.
Does the standard allow for bypassing guards for troubleshooting?
You won't find, I don't think, any standard that specifically says bypassing of guards, because that's part of what this standard is addressing. What they do state is, in one of the slides I showed you, is some of the operating modes. For example, in a CNC machine, there is something called a setup mode, where the additional measures are you can limit it to a jog speed, open up the door, but it only allows the spindle to go at a reduced speed under a controlled condition, but the axes can't move, as an example. Your Type C standards address those particular concerns, but when it comes down to what you would normally see on a, let us say, for lack of better words, a maintenance function, where a lot of times maintenance is allowed by their company to bypass the guards, or maintenance has become so known that maintenance is maintenance for the fixed machines, and they have to fix machines while they're running. A lot of the concerns when going through what maintenance has to do when people perform their audits or their risk assessments, they don't always take into account the maintenance people. They account for the operators, but they don't account for maintenance. And if you talk to maintenance about what they have to do, because the goal is not to make a job of a maintenance person's harder, maintenance people are just as important, or engineering people are just as important as the operator. Everybody needs to be protected, and you shouldn't be bypassing guards, plain and simple. Now, reality is, does it happen? Sure, it happens, and it happens under a maintenance condition. But when you go through it, you have to look at the considerations to say, do we really need to do it? Is it a function that has to be done by a maintenance, or is it more of the person is doing it out of convenience because they don't want to open and close a door? Is there alternative measures? So if they need to bypass a guard door, what alternative measures of safety are implemented, such as putting two-hand control in place so maintenance can have the convenience factor of troubleshooting, but binding their both hands for operation so their hands aren't in the machine, zoning it, putting a pre-start on the machine. So there are design measures in that particular mode that could be accommodated. And I apologize, I know that's a real long answer, but it's definitely an issue out there in segregating what somebody can do, but the standard is not saying you can bypass guards. It's doing just the opposite. It's trying to tell you that we know that this is an issue, and things have to be put into place to try to prevent that.
How do you determine if ISO 14119 is applicable for your system?
Well, ISO 14119 is what's referred to, I mentioned in the very beginning, a B standard. There are Type A, Type B, and Type C standards. Type C will always take precedence because it's specific to a machine type or machine group such as robotics. The RIA 1506, for example, the anti-RIA 1506 for the U.S., or ISO, I think it's 10218 for Europe, is specific to robots and robot cells. They have specific functions in there, and they take precedence. Type B is specific to a group, and why this is considered a Type B is it's not specific to machines, meaning it applies to all machines, but it's specifically dealing with interlocking principles of guards, not the entire machine function, not the whole guarding function, but the interlocks on the guards. Where a Type A standard is a general standard, such as ISO 12100, defines general principles of machine safety as well as risk analysis. That applies to every machine function. It's not specific to a group. So to answer that question, because 14119 is a Type B standard, it can be applied to any machine that deals specifically with guard doors that require interlocks.
Is retrofitting of existing equipment required, or does the new requirement only apply to new or modified equipment?
That's a very gray area question where the ISO standards don't necessarily go back and look at previous, because previous standards have taken into place, but also in particularly in the U.S. when it comes to machine safety, there's no such thing as grandfathering, where your safety devices aren't necessarily grandfathered in. Doesn't mean that you have to go back and start changing everything, but what it does mean is when you go through your risk assessment process, which you should be doing periodically to ensure you have safe operation of the machine, you have safe, properly working guards in place, looking at that and looking once you find one broken key or a manipulation that a key is removed, you know you have motivation in there, you know you're leading to a chance of defeat. Should you go back and modify the hardware to minimize that? Absolutely, but you have that standard as a reference to go by. It can create a big issue going back to a whole bunch of existing machines on a plant floor, but reality is, just like any machine standard or just a simple machine guarding concept, if you have issues on your machines that are not taken care of and they're going to lead to the loss of the safety function where somebody can get seriously hurt, you should be looking at those measures regardless of what standard it is to put into place to minimize, if not eliminate, that possibility from even occurring on a machine.
If individual machines inside a cell are guarded, does the motion have to stop inside the cell for those machines when interlock is open?
All right, say that one more time for me, Steve.
If individual machines inside a cell are guarded, does the motion have to stop inside the cell for those machines when the interlock is open?
The answer to that, I default to this a lot. It comes back to your risk assessment. When you open up a guard door and there's smaller machines in that guard, does motion have to stop? Well, the answer comes down to your risk assessment, because it depends if hazardous motion is taking place that somebody can get to. If the machine is completely encapsulated where people cannot stick their fingers in there to get hurt or cause a defeat, is there any hazards posed to the operator or maintenance at that particular time that you need to shut down? It's also areas where some people will zone machines, where if I open up the left door, I only shut down the left side of the machine because I cannot get into the right, and vice versa. So it really depends on the machine design and the function, but ultimately comes back to your risk assessment. If there's hazards that somebody can get to, when you open up that door, yes, they need to be shut down. If they can't get to hazards, the whole concept behind door interlocks is not to kill power to the entire machine, but to remove any of the hazards, initiate that stop of any hazardous motion, pressure, actuation, anything that can cause serious harm to somebody.
Okay, Mike, is there a good source for risk assessment forms or documents?
Some of the Type C standards have some of those. I want to say ISO 12100 gives you a very good overview of what to do and what the process is and the hazards to go through. There's not one end-all, be-all resource that I can point you toward to say definitely use this as your source for risk assessment, because at the end of the day, it doesn't matter what methodology you end up using. Now, the ISO standards, like ISO 13849, do specifically reference ISO 12100, but it's just a good guide. It's a good resource of what type of hazards to look for. But there's no specific forms in ISO 12100 to use. They give you some examples of things. But at the end of the day, you can create your own Excel file, list out your questions, and answer those questions. Do you have this type of hazard? Do you have this? Do you have this? What are the design considerations? Do I have this type of guard door? Do I'm using the proper interlocks? And answer those questions and put a value to those. So you can create your own decision tree and value factors, but some of the Type C standards have some of their own risk assessment methodologies they can use for specific machines that you can migrate over to anything. So unfortunately, I don't have a clear answer to say go to this source, but ISO 12100 as well as the Type C standards can give you some guidance there.
Well, here's a tails in on this question. Where can I get a copy of the new standard?
Any of the ISO standards you can buy from the ISO store online. I know ANSI, for example, sells a lot of the ISO standards as well, where you can go to ANSI.org, and they have an online store that you can buy the standards through. You can go to places like, I think it's called, you got to forgive me, I don't remember the full name. It used to be called Global Documents. I think it's IHS now. But the Global Documents for printed copies, you can buy standards through. They have a website, and they sell the printed versions of the standard, where ANSI can do the printed or electronic PDF copies. So that's where you can buy a lot of those standards.
Here's a question. With respect to the pie chart showing 25% of accidents were due to bypassing, can you clarify, did you say the 25% were fatalities? I would assume then that there were only more injuries than there were fatalities. Is that correct?
From what I have read and deciphered and got from some of my colleagues in Germany, they were revolved around the fatality aspect to it. So yes, there's probably a lot more on the injury rate that weren't reflective of that chart. And could that change that percentage due to bypassing? It's possible, but that was just one of the factors that were given in the report.
Has OSHA incorporated this standard by reference?
No. Nope. A lot of the standards that we use in machine guarding today are not incorporated in the reference into OSHA. One of the issues is to put something in the OSHA does take an act of Congress, and it takes a lot of time. And by the time the standard does get implemented into OSHA, it's already been updated and changed. The average that I've seen is standards get updated every 3 to 5 years. So by the time it actually does go through and get incorporated, it's already been replaced with a newer version. Now, in saying that, just because OSHA has not incorporated it, OSHA does make a statement that they encourage employers to use voluntary industry consensus standard because they are more up to date than a lot of the existing OSHA standards, and they give you a lot more detail and guidance. But they do make a stipulation that an industry standard will not override an existing OSHA standard. So you can't use an ISO standard and say, well, I'm using this instead of OSHA 1910.212 for machine guarding. That's not the goal of it, but 1910.212 is also very generic. So what OSHA does come back to a lot of times is the aspect of that it's, even though it's generic, but it may come down to that the general duty clause, protecting your people from serious harm on a machine. And that gets covered a lot in the industry consensus standard. So even though you won't necessarily receive a fine from OSHA to say you didn't follow ISO 14119, you'll never see that. You won't see a fine, you didn't follow ISO 13849 from OSHA. If somebody got hurt on the machine, OSHA would issue a citation on the general duty clause or the 1910.212 because somebody got hurt. You did not protect them from serious harm. But in the U.S., it's really more the litigation where you see that the lawyers that are working with people that have been seriously hurt on the machine know the industry consensus standards. They know what's out there, and they're educating themselves and their people to make sure that people are protected and they can prove a better principles and practices because the industry standards had given you guidance and you chose not to follow it, kind of thing. So it can get definitely a little hairy there. So I know that's a long answer to the OSHA question, but it won't be incorporated in the reference.
Well, thanks, Mike, for your input. We have quite a few more questions, but unfortunately we ran out of time. On behalf of EHS Today, New Equipment Digest, and Machine Design, I'd like to thank you for joining the webcast today. Thank you, too, to Schmersal for sponsoring the event for us today, and have a productive remainder of the day.